Dr. Rhem, I'll turn it over to you.
All right, all right. Thank you, Shannon. Thank you for inviting me to speak on this topic. Although IoT is something that I've been involved in over the last 5 or 6 years, it does offer an amazing opportunity to integrate two areas of expertise, or two disciplines that I'm very familiar with, very skilled, and have a lot of expertise on, and that is knowledge management and artificial intelligence. And so this presentation is going to take you through um, how IoT and KM and AI kind of fit together. A little side story. I participated on the keynote uh, panel for the um, KM World in 2019, and we talked about knowledge management in the age of smart machines. And so when Shannon and I was talking about doing this presentation, I thought about what a great segue to really talk about IoT and how that fits in the smart machine paradigm, so to speak. And so I'll be talking from those perspectives, and just hearing the introductions of the folks here tonight. I think we're going to really have a rich conversation because you guys bring a great amount of expertise to the table when it comes to IoT. And so looking forward to that. Um, so as a premise to this conversation, um, I'm looking at really some of the research that Gartner has done. And what they have found is that cognitive computing, AI, machine learning in particular, really is the backbone of enabling smart machines. And so, in the landscape of smart machines, of course, you have a lot of researchers pushing the paradigm, pushing the science. But we know and we've learned that IoT and industrial IoT brings a lot of value to enabling smart machines. And so that enablement is further facilitated through knowledge management and artificial intelligence. And as you guys can imagine, IoT is going to be, and it's already starting to affect, impact our lives in everything that we do. So we'll talk more about that as well. So if we look at what are the characteristics of smart machines, one is the efficiency. So with smart machines, you have sensors, you have ways to monitor what the machines are doing, what the machines are, how they interact with not only other machines, but people as well. And the smart machines really utilize intelligence um, downstream and upstream as far as the communication is concerned, applying specific business rules that you would leverage in this implementation. So it's the efficiency of doing, working with data with those sensors that really is the first step in a smart machine architecture. The next is safety and security. Now, you can imagine as more machines become interactive, not only with people, but between themselves, uh, you have to have a level of security and safety as well, especially in an industrial setting where you have machines operating with very little human interaction. And so security is a key element in the fundamental design of IoT and IIoT, and is a fundamental piece of the smart machine paradigm. Also, we look at flexibility, right? So smart machines enable us to do things in a more flexible manner. right? And these machines and architectures are are designed so they can fit into a myriad of environments. And what we try to do is enable the smart machine architecture to be able to leverage current environments where possible. And so as a consultant, I work with a lot of organizations, and when we try to move to the next uh, paradigm of either software or some kind of paradigm, or even a shift in how they work. I try to leverage the current environment as much as I can before recommending purchasing other software or other tools, because what I've found is that a lot of companies will look at the next shiny toy and say, okay, we need that, but not understanding how that will fit into your entire architecture. And smart machines is no different. And so um, that is one thing we want to emphasize, is the flexibility that that has to be there to implement smart machine technology. The other piece is connectivity. So smart machines enable that connectiveness to share data. Now, I always, well, not always, but at least in the last several years, I've been preaching that data is the new currency. And so uh, the ability to share and understand your data is key to um, driving revenues, driving decisions, and things of that nature. And smart machines allow you actually to do that, and helps management understand, or enables management to put more thought into the data that they collect and share. So giving those characteristics, you know, they're more, but these are the prime characteristics that I found really fit into that smart machine paradigm. Yeah, efficiency, safety, security, flexibility, and connectivity. Now, as we transition into IoT, taking that foundation, we know that IoT follows the same type of paradigm. So it has it aligns with the efficiency of smart machines through the use of sensors, like we said earlier, providing the ability to monitor key components of the environment, different conditions that the machine will be interacting with, whether it's an automobile and understanding the speed and distance that is traveling, objects that are around it, to your home devices, which understand temperature and time and room size. In the example of a thermostat, it's those sensors and efficiency in that those sensors and understanding that environmental conditions that IoT brings to the table. Also, safety and security. Now, we know from experience that anything that's connected, especially IoT now is connected through the internet, from your homes to cities, the internet, the grid, it's connected, the connectivity that happens. You have to have security in place for that, because as we know, there's always folks trying to hack into just about anything, and having security and high level of security in these platforms is a must, right? So we have to build data security within IoT designs as we are thinking about how we're going to deliver IoT solutions. Also, the flexibility that IoT architecture being compatible with your current architecture. You also have organizations and software companies and, like Microsoft and IBM and so on, that have IoT solutions that have bring to the table some built-in security and safety as well with that, and also it brings in a level of flexibility to integrate with other architectures in your firm, in your company. And so that efficiency, safety, and security, and flexibility, again, really aligns with what IoT is bringing to the table. And of course, the connectivity. So without the connectivity, IoT, of course, is not possible. So with the connectivity, ability to share, ability to communicate with machines and with people, really it allows IoT to really work and really work well when it's all blended together. So now we have a basis, right? Okay, smart machines, we know IoT is, I call it the backbone of enabling smart machines. We know that you know, we have four major things to think about: efficiency, safety, the flexibility, and connectivity. So now let's move forward a little bit, understanding that basic paradigm, that basic architecture. And I'm going to now bring into the table knowledge management and artificial intelligence. How do these things, these disciplines play in this space? And so with knowledge management, well, knowledge management is really about getting understanding how we collect what we know, distribute what we know to other people so they can learn and apply it. Knowledge management also is a way to enrich decisions and decision making. And so knowledge management and IoT kind of comes together from the context of the information that is leveraged by the IoT device. And so knowledge management plays a key role in understanding what data the device should collect. Like I had said before, I had an example of a car. And so if you have an autonomous vehicle, so some of the data that you want to collect is also driven by the knowledge, the things you want to know about the car and the movement. You might want to know speed. You might want to know the distance it's traveling. You might want to know the conditions of the road. You may also want to know the condition of the driver and understand if the driver is impaired or the driver is not paying attention to the road or what they're doing, and certain sensors built into the car having an IoT architecture will control the different aspects of the vehicle. It may slow the vehicle down. It may alert the driver with a beeping noise or things like that. So knowledge management actually is the basis for understanding what data you want to collect in the context of that data. So the points I have here is infusing KM with IoT is about going from data to information to knowledge. So, you know, data is those bits and bytes and, you know, the actual information, not quite information, but actual bits that you would capture, like numbers or to represent speed or things like that nature. But also the context of that information put together, of that data put together creates information. And what action is taken is the knowledge that is going to be leveraged. Like I said earlier, if we have a driver in the vehicle and the weather is bad and the driver is going too fast, the car may, automobile or vehicle may automatically slow down based on the conditions. So that takes those data points together to form information and then an action, which really is the knowledge that it's going to use. So it's those things that knowledge management or KM plays a role in the development and design of the IoT solution. And so that's actually, you may think of it as one of the key ingredients of a great IoT solution. So leveraging KM IoT platforms, indicate here, have a potential to activate insight from data to improve processes and resources. So you can imagine, I'm going to apologize for being on this car example. But you can imagine that, say, a manufacturer of tires will look at data from vehicles to understand what tread is best suited for certain conditions and stopping radiuses, right? Stopping distances. And based on the data and information and knowledge gathered from the IoT within the car to actually inform how to best develop a tire. Or it can also inform how to best develop the vehicle itself. So these are the things that come into play when we look at designing IoT, leveraging knowledge management as a basis for developing that architecture. So we want to tie incoming data to validate and drive business process models and decisions that are made. And again, it depends on the device. It could be heavy equipment that is used, and may want to figure out what's the best way to use the equipment in certain conditions. In agriculture, you may want to understand what machines work best and to collect different types of fruit or vegetables. It's a myriad of things that you can look at and analyze based on the IoT within the machines that you are working with, and the data and sensors that are collecting that data and information. And so we now know that KM plays that key role in pushing that IoT forward into a new perspective. It's probably some things that you guys, I know, in this audience have already, innately thought about in your IoT designs. But this also brings a specific focus to it. And for anyone researching IoT, one of the areas that is open and that there's not a lot of research being done is how knowledge management affects the IoT design. So that's another key area of research that may want to look at as well. Okay, so let's take a look at KM Infused IoT. I know I've probably talked through a lot of this already, but one of the things that we look at for KM and IoT is that procedural knowledge. Knowledge-based IoT explicitly represents data in relationships to sensors, systems, equipment being monitored to facilitate decision making. Just what I said before. It's everything being monitored that would then facilitate a decision, but all of that is determined up front in the design of that IoT specific application for that particular device or machine. All right. The next one is the decision-making aspect. We talked about how the data and information together will trigger a decision. And so knowledge management helps define what that data is, right? And how it would best serve the decision-making process for that particular device. I can give you guys a scenario where you are at home and you're having conversations with your family, and you have something called a Siri or an Alexa or Google Home, kind of just close to you, and all of a sudden you hear that wonderful digital assistant reach out to someone that you've been mentioning in your conversations, and actually call that person. So that has actually happened. So what occurs is that device is in listening mode, it's picking up data from your conversations. That data then triggers a response, and that response is to call a certain person. And so that's some of the power of the IoT in the home and in those devices. And that decision being made to make that phone call is coming from all those different data points. So those are the things that are involved that we really have to think about when we're designing IoT applications. Because at the end of the day, what that situation I just described tells you is collecting real-time data, right? Just like with the car example, it's collecting real-time data, and it enables that knowledge and that interaction to happen right away. Because because what I do a lot at home is I get up and I say, hey Google, what's the weather? And uh, I always expect the Google the assistant really to answer my questions, right? So it's like a habit and before digital assistants, we would turn on the TV or the radio or try to find the local news to get the weather. See the IoT is really we will talk about this a little later, being intertwined within our daily lives using real-time data. And KM and IoT together uh, can track large amounts and variety of data points. Now, depends on the device, it may collect thousands of data points, and that is a huge opportunity to influence decision making for a particular device or machine. So KM infused IoT happens uh, at the beginning of the design of your IoT architecture and solution. And it brings to the table procedural knowledge, decision making, real-time data collection, and you know, uh, enable you to get the right knowledge to the right people at the right time in the right context. And that all that is understood at the beginning of the IoT journey in designing that solution. So leveraging KM brings that to the table when we think about IoT applications. Okay, I know artificial intelligence is the big buzzword now, but we're gonna get into some specifics with AI and IoT. And I know from my audience, I think a couple of people mentioned that they are dealing with analytics as well within the IoT environment. So for IoT and AI, which we really focus on machine learning in this case, because AI is a multi-discipline science, and every time I hear people talk about, we want to do AI, I'm always thinking, what type of AI? And so in this case, we're really speaking of machine learning. So AI and IoT, one, integrated with providing that framework for analytics, equipment monitoring, from the car example I talked about earlier, through your Google Assistant or your digital assistant. AI through machine learning is enabling those devices to continue to learn. At the end of the day, it's a common thread between all the IoT interconnected devices, right? So you're collecting data through sensors, you're collecting a myriad of data points. Those data points come together to make decisions. That's design is based back, if you leverage your knowledge management, really driven from that perspective. However, with AI, it allows the machine to learn from a personal perspective, we talk about the digital assistant, learn from the use of the machine over time, collecting that data over time. So when you develop AI algorithms, machine learning algorithms to understand the data, it's collecting that data and learning over time. So machine learning plays a key role in moving IoT squarely into the smart machine paradigm, right? Because it's actually learning. The equipment is learning as you use it and as people interact with it. So the one thing that we must take into account when we leverage machine learning within the different types of uh, devices or machines is that these machines are really actually simulating uh, being intelligent, right? It's simulating that intelligence based on the data, based on all the connections and understanding of when we design the system and understand what data we collected, certain data together will solicit a response, a certain response from the device or the machine. So we actually simulating intelligence and behavior. We also want to combine the benefits of of understanding how devices are interconnected, looking at those benefits and leveraging AI to extend or expand how the different machines or devices actually function, and not only between like for the example of digital assistants between the device and the person, but also between device and another device or machine and another machine. And so those areas of where AI is going to play a role as well. The one thing that I always talk about with artificial intelligence is that we want to try to keep the human in the loop, right? We want to try to understand how the machines are behaving, uh, where the or how the decisions are being made, and we'll talk more about that as well as far as the understanding the ethical nature of how IoT and AI will work, and make sure that we follow follow some ethical standards from that perspective. So we all know that IoT at its core is about having sensors, collecting data at various points throughout the process, throughout the life cycle of the machine. And actually, the more data we collect, the more we're able to understand how the machine behaves and have opportunity to monitor, not monitor, but actually change and alter that behavior. Okay. Now, so I'm going to go through a few points for, I guess you can see a little pattern with my presentation. We talk about an area, then we kind of go through some certain points about it. So for AI-enabled IoT, we want to boost operational efficiency. So by AI being able to predict operation conditions, detect and monitor where the sensors are bringing in data, and we also want to look for ideal conditions and outcomes from the data that we collect. And so as we use AI, we want to optimize the machines and devices that are in use to make sure that we optimize how they are used and the decisions that they make. The other point is better risk management. So we want to help the business and the users understand um, the different risks and and have the devices or the machines adjust to those risks, right? So in the case of when we talked about the automobile or driving and the conditions of the road, that is a risk to the vehicle, risk to the passenger. We can also look at the interaction between the different sensors and elements of the machine and make sure any risk that we have identified has been mitigated before this type of uh, machine and software is enabled for use. And so this is a way to do predictive analytics with AI to understand what those risks are and to have a mitigation plan in place for that. The next aspect we want to talk about here is how AI or machine learning would trigger new and enhanced products and services. And so we know from our interaction with um, our digital assistants, which are now becoming more prevalent and within our vehicles, that we can actually talk to the vehicles and talk same way we talk to a digital assistant, and understanding natural language processing is a way to look at opportunities to develop additional functionality, additional products and services, leveraging artificial intelligence and IoT. I know that there is current research um, that is looking at how artificial intelligence is enhancing and moving IoT into the future and what that future may look like. And we'll talk a little bit more about that as well. I'm pretty sure a lot of you guys already have some ideas of how that actually is going to look. So with that point in mind, the IoT also increases scalability, right? Being able to scale and evolve the um, the the machine devices, the applications, the the capabilities. Like I said earlier, we have organizations such as, I'm going to refer back to like IBM with IBM Watson. IBM Watson has IoT platform. I know Azure has an IoT platform, and so it brings more and more capabilities and services through those platforms for an IoT centered architecture and applications. So that scalability with AI is allowing more and more opportunity to expand on what IoT can actually accomplish, which is um, which we talk about more when we talk about smart homes and smart cities. So, segue right into that. What we see now as the current landscape for IoT, and if we talk about the home, right? So, back to Gardner and some of what the research they have identified is that the adoption by this year, right, by 2021, is going to really increase, right? And we can see that happening, just by our own interaction and our own homes and people that we know as well. Um, and smart machines in general, if you look at artificial intelligence, it is going to present some disruptive technology opportunities. And so as that evolves, it's going to be more opportunities for that. And as we said earlier, the scalability of IoT with AI will facilitate more and more opportunity to expand the science. So IoT integrated with knowledge management and AI specifically machine learning. Let's talk about that. Well, actually, in fact, really play a role on how impact how we interact with our devices and with machines that we work with. You look at a automobile assembly plant and how a lot of robotics are in place there, and a lot of machinery are operating without a human intervention to down the assembly line, but the human is then in the process. Those type of things are happening currently within the IoT landscape. And the other thing I want to mention is that I don't know when the last time you guys have looked at um, new washing machines or refrigerators or dishwashers. If you notice, one thing is that they are Wi-Fi enabled. So Wi-Fi enabled device, that appliance allows IoT to be inserted. And so a lot of times you also see those appliances and have and indicate that they're compatible with Alexa or compatible with Google Home. And so now you can say, okay, wash machine on to your Google device, and through the IoT and the connectedness of the machines, that will solicit a response to the particular machine, the wash machine, whatever that you are referring to. So that is that all that interconnectedness allows for the smart home to really evolve into um, every machine interacting um, by you just um, talking with it, which I'm dating myself, but this cartoon called the Jetsons way back when the future, and they just talk to the machine, and dinner comes, and they talk to the machine, and car comes to the house, to then they jump in and go to work. It's those types of things. If you look at I'm a Trekkie, so you look at Star Trek, you know, talking into the devices, having interaction with devices, and something happening, food being delivered, uh, you know, people being transported from one place to another. So these are the interconnectedness of the devices that we are starting to see more and more interaction with human and devices, and the interconnectedness through the internet, and that is key. So when you next time you buy one of those appliances, you can see that they are, a lot of them are Wi-Fi enabled. Okay, so given that aspect, our current landscape looks like this. So we have mobile networks for asset tracking. So we can track assets through our mobile networks, whether it's inside the home or outside the home. Years ago, I worked with the U.S. Army and helped them develop the first RFID uh, application. Now, what that RFID application did was it tracked ammunition from the manufacturer to the soldier using RFID technology. The barcodes, right? Put barcodes on the boxes of live ammunition. You scan that, you know where it's at every step of the way. With IoT, with sensors, now you can automatically scan that and know where that package is, or that in that case was the ammunition. But it evolved that RFID technology to have sensors right there on the packages. As you guys can see in the stores, you walk out the door with a sensor on the package, it's gonna go off, right? So it's that type of technology that is in the current landscape of IoT and it does a great job of tracking assets. So that is something that we are living with today and actually interacting with every day. So we talked about earlier digital assistants, those wonderful um, Google home devices, Alexa, Siri. You know, pretty sure you guys got that on your phone, cell phone too. You can talk to it and ask it questions. I know my son is always asking his phone to do certain things or asking it to Google to do certain things. And I just kind of shake my head and said, when I was growing up, we would look something up, look it up in a dictionary, or do some research in the library. They go right to their phones or the Google device.
The
So
opportunity to come.
um, the next one is the AI IoT that we talked about earlier, and how that is now in 60% of the IoT activities. This is straight from not Gartner this time, but McKinsey. That really 60% of the IoT devices has some sort of machine learning. Um, the home devices definitely do because they are learning. They are constantly learning you, learning what you do, learning what you say, learning what the response should be. Especially if you have it, continually have it in listening mode, and you might want to turn off listening mode. So that may be something to do. In industrial IoT, of course, is gaining huge traction and combining connected products and applying IoT enabled analytics. I know we have some people on the session today that work in IoT analytics and especially with IoT, industrial IoT. Analytics is playing a key role in that landscape. So that's the current landscape with IoT. So we looked at how IoT really is the backbone for smart machines and how CAM and AI helps facilitate that. All the different aspects of understanding one, what data are we capturing, what decisions are we making with that data. AI is learning, how the machines learn and evolve by understanding the more data you collect, the more machines are able to learn. We understand more about, we interact a lot with the current landscape of IoT, but let's take a little
Hey,
peek into the
Tony,
future. Yes.
I just want to do a time check because we're getting to the hour mark. Do you think you could wrap it up in about 5? And
Well,
then we have a little bit of time for discussion?
I can do that. I got on this role. I was really talking about some really key aspects and people were dying to hear, but yeah, I could definitely speed it up. So let's look at the future, right? So because we know we're living with the IoT. Of course, we're going to have enhanced security, edge computing, which I'm not sure if a lot of you guys know about edge computing, right? It's moving the data closer to where we need it. I know some people in the audience are cloud computing experts, and they understand edge computing. Of course, we go keep talking about CAM and AI, and of course, the other thing is digital twins. Really creating that environment, that physical environment in a digital space. So that's some of the future landscape of IoT. Again, sometimes, as in the course of presenting, we speak on things that we are going to talk about later. And one of the things is smart homes, because thanks to the interconnectivity of Wi-Fi and mobile devices, we're able to put these devices together, like we were talking about earlier, and create a smart home where everything is connected in the home, and you can have that interaction with your devices in the home. And as that smart home now evolves, now we move into the smart cities, where everything from the city has the possibility to be connected. And so with your cell phone, you can tap into, oh, you can probably do some of that now with some of the apps. What's the best restaurant? What time is the next train? It's just everything connected that gives the city and city management a, um, a a bird's eye view on how to improve services that the city offers. So that's one of the things that the smart cities will give us. Again, where we go in the future is security. Everything that's connected needs to be secure. I mean, and everybody on this call understands that security is going to play a key role moving forward, especially understanding cybersecurity. So the one thing I want to touch on a little bit here is some of the jobs, and you can kind of figure from my conversation that with AI, it may replace some jobs, but it's going to create others and enhance current jobs. And so again, Gartner predicts that around 75% of the IoT projects will take twice as long because of the lack of talent. But I'm here to tell you that we do have talent that can be not more or less retrained, but reskilled in IoT knowledge. And I know a few people have already talked about, they're doing their PhD in the IoT space and learning more about how IoT works, from folks with AI background to the cloud background, the UI UX background can do that. Also, understanding about chips and sensors, communication gateways, all those other skills come into play for the entire IoT background. Also, it's stated that the global internet IoT market is going to reach at least $320 billion by 2023. Huge market, huge opportunity. As you guys know, you're in a great space that's going to continue to evolve. So, opportunities: connected customers and technology, IoT devices, providing training to the next generation, AI, ML engineers focusing on IoT and IIoT appliances, what we talked about earlier, how that's going to be connected and having people that understand how those machines work and to be able to repair those machines, appliances in this case, and creating standards around IoT and IIoT. I know that GE has a standard for industrial IoT, and so that they have been pushing that over the last several years as well. And so also we talked earlier about ethical issues. And so there are some things that we need to understand from an ethical standpoint about the information security, physical safety, and trust of the machine. And with the data that's being collected, and again, you start early in this discussion in the design of the IoT architectures. So, in conclusion, I definitely want to thank Shannon for inviting me. And sometimes, since Shannon, she probably sensed it, but she should have stopped me a little earlier to kind of speed me up, because I will have these stories and I can passionate about the technology and keep talking about it. But anyway, as we talked earlier, concluding, AI and KM, edge computing, digital twins, those aspects, those disciplines are bringing a lot to the IoT landscape. And that is going to be the catalyst for the next era of IoT and IIoT applications, architectures, and devices. From our homes to our cities, to how we work, and to how we live in general. And so that is my presentation. I thank you guys for having me. I apologize for,
No, Tony, it was great. That was great. Thank you for that. And yeah, I'm seeing great presentation. I got to read some of the comments. So I think some people would really like to, they kind of held all their questions to the end. It might have been because I was muting everybody because things were I'm starting to hear some background noise. But I would like everybody to come off mute if you want to talk and ask some questions or just have a conversation. I know Catherine Huff was asking some questions. Sounds like you're in retail and doing some RFID tags. I'd love to hear that discussion.
Oh, okay. For
Hi,
me,
this is Mike Bacino. I have a question, please.
yes.
Go ahead, Mike. And we'll go back to Catherine.
Oh, sorry if I hijacked that. Great presentation. Thank you for your time and expertise. You mentioned that all IoT related services follow 5 steps: create, communicate, aggregate, analyze, and act. And I'm interested in knowing, in your consulting work, where organizations fail most commonly and why.
Well, in the IoT space, they fail early on in understanding what data needs to be collected and how that data will be used. And so what happens is a lot of times they will end up coming back and re-engineering the application to be able to collect that data. So that it fails a lot of times, from my experience, from the data piece.
Thank you.
I've actually seen some companies, a lot of them fail to even launch. They have a hard time monetizing.
Yeah.
So it seems to be the going to market seems to be a real challenge sometimes. But
I have a question as well.
go ahead.
There was a point in the slide around the security aspect in IoT, and there was this recent breach of the OT systems at a water plant in the United States through the IT systems, basically. So, I mean, how can, like, does it make commercial sense for organizations which are trying to sell these products to kind of work properly, right? I mean, for any entrepreneur or for any project manager, the key thing would be to kind of make the solution work. How how feasible is it for them to kind of look at privacy by design or security by design from the get-go, like before the project starts? And how and how can how can they be made to do it, essentially, even if maybe commercial, they're just focusing on the commerce of it and not really on the other part of it, but how can they be made to do it, or how can they be kind of incentivized to do it?
Yeah, that you make some great points. One, because you're really trying to sell a product and get it out and actually drive revenue. So when it comes to security, when it comes to understanding data, when it comes to any ethical issues, those are the things that need to happen up front in the design. So, and understanding what is the risk and understanding risk management. So there's 2 things. One, from an internal perspective, when you're building the applications and and leveraging the machinery that will use the technology, is one, internally doing it, but then working with your customers, because they have other security issues and concerns once you deploy in that customer's environment. So there has to be an intentional piece in understanding what security protocols you need to adhere to, and the not only from the internal company, but also to the customer as well. And that has to be within, or be getting beyond the science, but within the contracts and agreements that are put in place. And to your point, that is the only way you can enforce or drive that aspect home, is having the customer also expect certain SLAs around security and have certain agreements. And if the security is breached, ramifications to be taken in that case. So that's that's the only way I see that can help that.
Thank you so much. Tim.
Anybody else have any comments on that? Okay, Catherine, did you want to? I know you were talking about RFID tags and some inventory, real-time inventory. Did you want to comment?
It wasn't really a question, more of just a comment when you were mentioning RFID, but just kind of how interesting that the use cases can span so widely. One question I did have, and I was working on formulating it, I think it really resonated with me, Tony, when you said, data is the new oil, and we're ingesting so much of this data. I know one of my customers, they have so many critical applications that they're just pulling, real-time data constantly. With that, almost, with great power comes great responsibility in regards to data and telling a story. Where do you think companies maybe go wrong with how they're manipulating that data and how they're using it?
That's a great question, because that's all in the news right now, how companies are misusing that data. And so it's one, understanding the ethical nature of the data that you have. And so and the other issue is with AI can, even though the data may not be an issue at the beginning, but with how AI can interpret it and put data together, it can then become something that is more than what you intended to be. And so consumer companies like Amazon is constantly collecting data, constantly, and they have all these new services. But I always look at what the data they're collecting and what they want to do with it. And so you have to have some level of transparency, especially when it's public people's data. But internally, that's where you have a lot of your chief data officers will have these standards and efficacy standards to help govern that data, and that's a huge issue. And it's not something that is resolved overnight, but you have to have those standards and policies in place, and understanding what data you're collecting and how you're storing it, and how AI is going to manipulate it and use it to make sure that it is used as intended, or hopefully the intentions are good, and to be monitored and governed along. It has to be intentional. It can't be haphazardly done, or, oh, by the way, let me do something about this, governing this data. It has to be as part of the policies and practices of the company. So that's a huge issue. It's a huge issue.
Good. Anyone else have some questions?
Hey, Shannon, this is Bob. I have one question. Regards to the cybersecurity, what are some of the advantages and disadvantages to outsourcing that security to a third party as opposed to developing something in-house?
Yeah, that happens. That happens a lot. So the only advantage I see is the level of expertise. If you don't have it in-house, is to get it from an outside source. However, what I do find is that the organization that is bringing in the outside resources have to have an ideal of what type of security they need to have, right? And so they can help have this two-way conversation between the vendor coming in and understanding from internally because you should know your data internally better than the organization coming in. So being able to understand and guide that organization so you both partner together to be able to come up with a solution that is that will secure your data and secure your facility from a cyber attack. So because it's the outside company may be experts in that area, but they're not really experts in your data or experts in how you run your business. And so the two together should come up with something that is um, uh, not only best for your organization currently, but as it evolves over time with what data you actually collect and use. So to me, it's a partnership. To me, it's you just can't let someone go in and just say, here you go and walk out. It has to be a partnership in that development.
Okay, thank you.
I almost think kind of going back to Asisa, is I'm saying that right? I'm not saying that right. But your question was, is it important and how do you start your projects or whatever? I think, you got to start day one with security and data privacy and understand how you're going to do it from the onset. It's not something you do at the end. You got to do it at the beginning. And then I think you got to test it, right? You got to keep testing it and making sure it's because the threat model keeps changing.
Oh,
And always making sure that your software can handle those new threats, right? So
absolutely.
all evolving.
Yeah,
It's
because
so important.
we talked about in the presentation about monitoring, right? It's that constant, like you said, Shannon, constantly monitoring and that those threat levels will continue to evolve because there's always somebody out there coming up with a new thing to break in.
Yeah.
And so that you guys have some great questions, and it takes a lot of thought, and those are critical questions, and a lot of companies are struggling with that. Absolutely.
Another question from my end. Um, um, so basically, for IoT devices, you need to kind of have power, right, or batteries, right? And I think that is something that's been limiting their scale, as far as I understand, in order for IoT to kind of truly take off. Um, so how do you see the industry kind of moving towards, like, how do you see the industry kind of helping out with that aspect um, of IoT to kind of help it scale?
Enabling IoT to tap into one, you need to have connectivity, and so you need to have power. You need to have um, uh, environments that can facilitate that. Whether it's if you look at other countries outside the U.S. where using solar, using other means of to generate power, the also connectivity through mobile networks and mobile cell towers, satellite is also the other piece there. And so there's two things: the power source and then the connectivity that has to be taken into consideration when you have IoT and be able to scale IoT, like you said. Without those things, without those two pieces, it's going to be impossible to do that. And so you have to look for the alternative ways to one, generate power, and two, have connectivity.
There's this one comment that I've been hearing at different conferences, and it's really they're saying COVID is a great accelerator. And there was a lot of reluctance to try to pull in a lot of the IoT, but since COVID happened, it is estimated that it has moved IoT adoption forward by 10 years minimally. So it's if it was going slow before, it's really picking up the speed now. So
I
at least
believe
from a
that.
corporate perspective.
Absolutely. Because we all, at home more and we're doing more things, using our devices, uh, working remotely. I mean, it's like you said, Shannon, it's definitely accelerating it.
And I guess that's why we're seeing this um, you know, problem with the semiconductor supply, semiconductor metal supply, right? Because like you mentioned, if the industry is kind of gone forward 10 years, then possibly there's a issue with the supply there, maybe. Um, so like any kind of from your understanding about the industry and discussing with experts and stuff, how do you think the industry is going to adapt to this issue of the problem of supply of the semiconductor metals and um, related raw materials when it comes to developing these IoT devices?
Mm. Right now we have the chip shortage. I think that's sort of evolving itself, but it's hard to say unless devices are made with other materials that not so much of a shortage. But like anything else, that could drive up the prices and things of that nature. But it's a balancing act, right? So we have to innovate and look for different ways to develop devices with different materials and and leverage as much as we can things that we know would be available. But it's hard. It's hard to understand. I mean, we like the chip shortage. It happened because of COVID and transportation and things and different uh, transportation systems stopping, and so that inhibited the transfer of ships across the world, and so everything is we are so connected globally that it's hard to say how if one thing happens, how it's going to have a domino effect on everything else. Just like you see the weather, what happened in Texas, and the grid there, just everything shut down. I mean, uh, who could have known that was happening or would happen? But so it's hard to predict everything, but you hopefully are prepared and have a backup plan to be able to help.
So, like, does it make sense in that way to kind of shorten the supply chains and, start thinking more locally than globally, if, to so that it just makes it easier that way?
Yeah, I think in theory, yeah, shortening the supply chain is great. But we look at where we're getting the materials from, and if locally we don't produce as much of those materials, or those materials are more costly for us to produce, then again, it's that delicate balance. But then that would drive up prices and of that particular device or that commodity, and it has to be a gradual move to say, okay, if we get cut off here, we have to have an alternate supply chain somewhere else. So if anybody on the call is expert in logistics and supply chain management, that's a good case study right there.
Yeah, the global supply chain, the threats and the weaknesses of it have caught the attention of the United States Defense Department for quite some time now. So in the Chicago area, you have one of the manufacturing institutes right on Goose Island that's tasked with trying to bring more of that manufacturing knowledge back to the States. And there's 14 other manufacturing institutes all across the country with different focuses, 3D printing, additive manufacturing, robotics in Pittsburgh, all over the place. So COVID's an accelerator, like you said, Shannon, right? But these institutes were set up about 10 or 15 years ago, primarily to shorten that supply chain of mission critical components, including semiconductors. And now it's affecting the automotive industry, and some of that's shutting down. So I think we're in on the brink of a resurgence of domestic manufacturing, because the other thing that's happening in parallel is consumers want more personalized and customized product. They don't want mass-produced products anymore. So that efficiency of large-scale production, the importance of that is going away when you're talking about creating one item, not a million items. And maybe getting it quickly is more important than getting it cheaply. So,
see, absolutely.
So,
and Mike, you bring up a great point. See, they started what 10, 15 years ago. That's the so if someone had to have some foresight, say, hey, and that's a great point that was brought up about shortening that supply chain, and you just can't think about it and just say, oh, we're gonna do that tomorrow. So.
Oh yeah, and I think it was quite startling when people analyzed it, how our country has competitors in the world, as everyone knows, and they have looked at the weaknesses of our supply chain at a very, very minute level. So you talk about the chips. Well, what are the materials that go into the chips?
Right.
What are the materials that go into the materials of those chips? And some of those third generation back products are tied up in monopolies in other parts of the world. There's zero domestic production.
Wow.
So you can't it's just not a matter of putting in a semiconductor chip factory in Chicago and saying job is done, because 3 orders of magnitude of the precursor materials aren't available. And they're tied up in monopolies in other parts of the world. So it's a huge issue.
The one thing I didn't talk about, but something that is one of the future points of IoT is incorporating blockchain with IoT, and to understand how that supply, especially in the supply chain, to your point, Mike, get to that minutia to the very, very beginning and understand how that whole supply chain works. That's an amazing opportunity for somebody.
All right, guys, maybe one more question if somebody has a question. All right, coming to the top of the hour here. I do want to thank you, Dr. Rhem. This was great, a very broad subject. You covered IoT very well. Lots of great comments. Hopefully you read those in the chat. And I just want to say thank you to everybody who attended. We do have these on a monthly basis. It is the last Thursday of the month. And I encourage you guys to go to the Peoria IoT Meetup and just join the group. You'll get notifications automatically. I send those out every month in the subject and the topic we're going to be discussing. I've also started putting it out on LinkedIn, where I think some of you guys have come from, and put it out there. Feel free to share that as well if we have an upcoming event, and invite others that might be interested in the topics. But great discussion. Appreciate all the conversation, guys, and I'm definitely thank you to Dr. Tony Rhem. That was a fantastic presentation. I do have it recorded, and I will post that probably over the weekend. So if somebody wants to rewatch it or wants to reshare it, feel free to do that.
Oh, great. Thank you, Shannon. Thank you, everybody. I mean, I learned quite a bit from everybody tonight, and really appreciate the interaction. Thank you so much.
Thank you, guys. You guys have a great rest of your day or evening. Thank you.
Great. Thanks. Great presentation. Thank you.
Thank you, everybody. Thank you.